Everything just freaking works. You better work. Okay, disk drive isn't connected. Okay, that's the antenna. Antenna lifts up. It's good. Disk drive. I good.
See you later.
Transmission. See you later. Oh my God, everything's working. I am building my own animatronic Claptrap from Borderlands, and it's been a while since my last update, but don't worry, progress has been made. In fact, a lot of progress. And I want to showcase all of those features today in what I am considering the last update before the main video, because the finish line is there in the distance, theoretically, if you squint. Can you see it? First I need to pick him up. All right, let's Let's set you down there. So why is my Claptrap so heavy? Well, I've gone to great lengths to keep him lightweight, so I designed parts of his body out of thin sheet metal, carbon fiber rods, and PETG plastic. But I need some things to be a lot stronger than that, like this shoulder bearing retainer, which I previously made out of PETG, and is now made out of solid machined 6061 aluminum, thanks to my friends over at PCBWay. Now, if you want to turn your 3D models into real machine parts like this, head on over to PCBWay.com and get yourself a quote. Now, I had them make my parts like this structural bearing block out of aluminum because I wanted maximum rigidity for minimum weight. But my Claptrap has a lot of parts, and he still clocks in at over 75 pounds. So, to make him easier to work on, I made this special stand for my junk pile so that I could mount Claptrap for display and assembly. Except it totally cracked the last time I transported him on there. The base risers were made out of PETG and reinforced with long screws, but at this point, I feel like it's a given that he needs a steel mount. Anyway, I'm not here to talk about this stand, let's talk about the good stuff. Claptrap has arms! Well, he's had arms this whole time, but not only are they working, but now I can control both of his arms in real time. That means I can flap, control his wrists, his elbow, rotate his arm, lift his arms out, and forward and back. I completely redesigned his shoulder so that each axis of rotation is driven by a separate motor. Frankly, I should have done that to begin with, but if I'm not learning something the hard way, am I even learning? Well, to be honest, I'm actually really excited to have Claptrap at this point, and this has been a huge milestone for me. Like, this is one of the things I've imagined from the very beginning, and it's so satisfying to finally see in real life. And as much as I want to call them good enough, they're not good enough. There's a couple more flaws in the design of his arms that I want to fix. In order to keep his shoulder compact and allow cables to pass through, one of his shoulder joints is driven by a gear. The Dynamixel servo inside his joint is plenty strong enough to lift up the arm, but the gear teeth are slipping. They'll hold up for now, but I need to redesign them. This also goes for the wrists. I've got functional wrists, courtesy of this smaller Dynamixel XL330 in his forearm, but I don't love the cable-driven mechanism. Tensioning the cable is a pain, and his wrist slowly loses tension as the inertia of his flaps flapping causes the cable to slack. For the final design, I'm going to use tiny timing belts directly coupled to the wrist joint. These are spares left over from my Wheatley build for his handle mechanism, so I know they'll do the job. Previously, I had Claptrap's main wheel mounted to posts that screwed directly into the bottom of the chassis. In my new version, I'm moving over to a more game-accurate suspension. Now, I'm using suspension in air quotes here because this isn't actually a suspension. The suspension consists of these angled steel brackets that slot into 3D prints that mate with the hub wheel axle. The springs are purely aesthetic because I need him to be completely rigid so that he doesn't lean to one side. This also helps with clearance when Claptrap retracts his wheel into his body. Now, that last feature sounds crazy, and it is. I've spent an excruciating amount of time hollowing out his body so that he is split into two main parts: an inner body that can raise itself up with a linear drive system, and the outer body that can articulate around that inner body. Now, since Claptrap is a big boy, I need serious torque in order to raise and lower his body. Thankfully, Robotis sent me their new Dynamixel Y, which is an incredibly powerful and precise servo. In my system, the Dynamixel Y drives a gear which is attached to a lead screw. When the lead screw spins, it drives a brass nut that is seated in a carriage that attaches to Claptrap's suspension bracket. The carriage is guided by 4 linear rails that are mounted to the steel frame that encloses his brass flywheels. Okay, so does this part hold up, and does the mechanism even work? Actual rising test 2. Oh, Oh, that sounds so good. Oh, there we go. That sounds better. It almost broke itself. It's like he's really a robot. Oh man, I'm so tired. Yay!
You look like you want to die.
It's not breaking any speed records, but it's moving smoothly and has torque to spare. I think that'll do for now. Now, I want Claptrap to be able to move his whole body relative to his main wheel like he does in the game. So I've attached 2 giant servos to his inner chassis. These push on his upper head plate, that is the core structure of his outer frame. Now, there's a lot going on internally, so we can only articulate plus or minus a few degrees, but I think that's enough to emote. In the final version, these servos are synced to an IMU, which is a sensor that allows me to measure orientation. The IMU is inside the custom remote control that I use to puppet him. Surprise, surprise, there's a big problem with the current design. You see, when modeling him, I'm always imagining him on the ground or on his test stand. That means the weight of his outer body is always pushing down on the servos and the mount that goes into the inner chassis. What I didn't account for was all the tension this assembly had to bear when I picked him up by the built-in handle in his head. So eventually, the weakest link, the 3D printed servo mount sheared and shattered when I last lifted him. This part needs to be metaled too. I want my Claptrap to be as expressive as possible, and that means animating these little flappy bits. So I've added a servo to each side of his head to control the flaps, which are basically ears as far as emoting goes. This was very much a last-minute addition, but I'm so glad I added this feature. They work well, but in an effort to keep them lightweight, I made them a bit too thin and they're already cracking pretty badly. Thankfully, Claptrap is beat to all hell, and I've patched them with duct tape, which conveniently matches his aesthetic just fine. Now, Claptrap's eye is almost done. It looks right, it moves right, it glows, but it's a bit too heavy. Originally, I designed it with this 2-axis Dynamixel, thinking it would save space and complexity, and it totally does. But the nature of this form factor means that unlike a universal joint that I would normally use in a mechanism like this, the axes of movement aren't aligned. I mean, so what? While his pan motor doesn't have to resist the force of gravity very much, the tilt axis does. It also has to carry the additional weight of the servo itself. While it works for a little while, these servos will disable themselves if they're over-torqued, and his eye basically gets fatigued, and I can't control him anymore. I already know the solution for this though. I just need to move back to using 2 independent servos like I've done so many times, which I feel like is a pattern here, you know? So there's still more to do. All right, so there's one last feature that I haven't been talking about. It's sort of a self-balancing elephant in the room, if you will. Is Claptrap going to self-balance on his monowheel? Short answer, no. Long answer, well, also no, but there's a pretty good reason. You see, self-balancing robots eventually fall over. A lot. Now, you might think, that's fine, you can just put them back together. Well, Claptrap is a delicate and expensive, I was about to call him a little boy, but that's kind of weird. He's a robot. And if he were to fall over on his arm, and he's fallen over multiple times during the process of building this, I immediately lose hundreds, if not thousands of dollars, and have to spend a minimum of a week's worth of labor to repair him every single time he were to fall over. I frankly just can't afford that anymore. This project has far and away exceeded whatever concept of a budget I had in the past, and honestly, I want it to be done. You know, I could have made self-balancing the #1 priority in his design, and it's always been a core feature. I've always incorporated that. But my main priority is to make something that feels like Claptrap and makes people happy. You know, I actually got to test this out in person by bringing him to Hackaday SuperCon and showing him off to people. And frankly, the response was fantastic, and he wasn't even complete then. And that's exactly what I want. I want to make people laugh and smile and make them feel like they're interacting with Claptrap in real life. So that's what I'm aiming for, and that's what I hope to do in the final video. Thanks for watching.